Hi everyone, in this video we're going to discuss the question on UPS. For the first question, every natural number, so as we know natural number is the smallest subset, then bigger will be whole number, then followed by integers, then followed by rational, and lastly all of these is under the set of real number. So every natural number inside here is an integer number, is a real number, is a whole number, all of the above as an option. Next, find the argument for this complex number. First, we draw out the Argand diagram where A is 2, then B is negative 3. This is for imaginary part. This is for real part. So this complex number fall in quadrant 4. So the argument will be equal to the negative alpha. So negative shift tangent B over A. B over A here, always remember, is a scalar quantity, is a height of the triangle. So actually this is our triangle. It will be the height of the triangle, which is 3, and the base of the triangle here, which is 2. So here we have our option 2. Next, given that the set of x is this, and it is a whole number, and the set of y is this, and it is a real number, find their union. First of all, we draw out the number line of the x. It will be starting from negative 2 until 3 whole number. So whole number means only involve 0, 1, 2, and 3. So 3 is equal, so it is included, and this is whole number means the solid number only. In between 2 and 3, we don't have number, so don't drag the number line here. So this is our number line of x. Then number line of y will be all the real number, means all involve the decimal. Start from negative 2 until 2. So negative 2 is included, 2 is not included. Then to combine this, to do the union, we're going to combine where we have the number line, that will be our answer. So we will take until here. So 1 is not included, this is included, so continue, we combine means it is included. So our interval will be start from negative 2 until 2 and the number of 3. So together, the number of 3. Therefore, we have this option. So for this complex number, we're going to expand and then we're going to compare what is the real part as the value of x and what is the imaginary part as the value of y. So compare, we get 3 minus 3i, then plus I, then minus I squared. I squared is negative 1, so negative become positive 1, so 4, then minus 2i. As we compare, x is 4, then negative y is equal to negative 2, y will be equal to 2. So here we have our option. For the next questions, given that the complex number z is 5 plus I, find the conjugate and time with I cubed. So the conjugate time with I cubed. The conjugate of the complex number will be 5 minus I. I cubed will be negative I. So expand this, it gives us negative 5i plus I squared. So I squared is a negative 1. We write the real part first, followed by the imaginary part. So here is our option. Next, write the conjugate in the polar form for this complex number. So the conjugate is 3 minus 3i, with the data is negative pi over 4. So 3 minus 3i, the complex number in quadrant 4, with the argument is given. What we need in polar form is the modulus of the conjugate here. So the modulus will be a squared plus b squared. So square root 18, it will be 3 third 2. So put in our polar form, it will be 3 third 2, then cos theta plus I sine theta. So here we have, this is our answer. Then solve for this. So 4 to the power of 5x plus 2. So we can put it as a base of 4 to the power of 3. Then we compare 5x plus 2 is equal to 3. 5x is equal to 1. So x is equal to 1 over 5. So in this equation, we don't need to check answer. The x is equal to 1 over 5. Here we have the option. Then find the solution for the log equation. So as we can see, log base 3. Here also having the log base 3. We can move it to the left hand side so that log minus log. We can operate this to be a single log where x will over x minus 1. Then we unlock. So when we unlock, the base will be go to the opposite, become the base of indices, then 2 will become power. Therefore, x over x minus 1 will equal to 9. We simplify, cross multiply, and we move back. So x will become 9 over 8. Then we need to check our answer. When we 9 over 8, put back to the log, it is positive valid. So this one 9 over 8 can minus 1 equals to 1 over 8. So it is positive. So this answer is valid in the log equation. Then express x in terms of a. So we have 2 sub x. We take it as a left hand side as a subject, then 3 minus a. So we want to express x. To remove the square root, we have to square both sides. So once we square both sides, we get 4. Then this is only x. Here we have 3 minus a squared. We don't need to expand, as we can see our answer is in factor form. So x will be 3 minus a squared over 4. So we have our option 2. So here we have this answer. Then we check left hand side. Is it equals to the right hand side? Substitute this x back, square root for this x. So square root and square, we leave 3 minus a, square root 4, we get 2. Simplify, here we have a plus 3 minus a, we get 3, so equals to the right hand side. So this is our final answer. So this is not our final answer. As you can see, when we substitute a plus 2 third x, this is our left hand side. When we simplify, a minus 3 over 2, then here we have a plus a minus 3. We get 2a minus 3, which is not equal to our right hand side. Then find the solution of the inequalities. So first of all, we expand first. 6x minus 3. Then here expand 2x minus 8 plus 5x. So this is a linear inequalities. What we need to do is just move it to the left hand side for the x, and the value move it to the right hand side. So 6x minus 2x minus 5x greater than negative 8 plus 3. So we have negative x greater than negative 5. When you divide by negative, change sign. So here we have our option. Then for the next, when p is positive, q is also positive. What is the solution for this? So as we can see, this is a quadratic factorized. So here x is equal to negative p, and 1 is positive q, negative p at the left hand side, positive q at the right hand side, because they say this value is positive. So the coefficient here is negative. Then they want the positive shade above the x-axis. Therefore, our answer will be less than equal negative p and more than equal q. Therefore, we have this as our option. Continue. Obtain the interval that can solve for this inequality. So this is a rational inequality that we can see x at denominator. What we need to do, we make sure the right hand side is 0. Then we use positive number line. Let numerator positive. Denominator cannot be equals to 0, so it can be positive but not equals to 0, because the denominator cannot take the value 0. When it take value 0, it will become invalid. So x here will be greater than 3 over 2. Then we do our positive number line. 0 and 3 over 2. More than equal, then circle. Then positive, positive, negative. Then more than 3 over 2. The region got line is positive. The region without line is negative. So combine this one, multiply, we get positive, negative, positive. What we need here is the combination to get negative. So that will give us this region. 0 included, as we can see, 10 circle. Answer. Then 3 over 2 is not included, so empty circle. You can see empty circle here. Therefore, here we have our option. 0 is included, 3 over 2 is not included. Then find the solution for these inequalities. As we can see, this is a simple x, so we can move out the value. Minus 2, we get 7. Minus 2, we get 2. Then divide by negative 3. When you divide by negative 3, you need to change sign. So negative 2 over 3. Rewrite this in order. Start with the value of negative. Then follow the symbol. The symbol is face on the negative x. Then 7 over 3. Therefore, we have this option. Which combination are correct? So modulus 2x is equals to 3. When you do the basic definition, one is positive 3, one is negative 3. So this is correct, but your negative just move to the 2x only. Then 45 modulus less than, so bola. So less than, you must have the definition of n, so this is wrong. Then for this definition, if you have a simple, we can insert the negative in front the 5 minus x. So one is positive 2, one is negative 2 in front the modulus. So this is correct, 1 and 3. Then solve this modulus both sides. For this, we're going to rewrite the modulus in the form of square root and square. Then to remove our square root, we're going to square both sides. So square root and square simplify, we get 2x plus 4 square. Here we have 4. Then square root and square, leaving x square. Expand this, we get 4x square, 16x, and then 16 minus 4x square less than 0. So as we minus here, we cancel our 4x square. Therefore, we have 16x is a linear, so move back the 16 to the right hand side, divide by 16, negative 1. So it will be less than negative 1, means negative infinity until negative 1, not includes because we don't have equal here. So here we have the option. Then for this term, n plus 4 is 3n plus 17. Common difference is 3. Find Tn plus 5 in terms of n. So what's meant by this? You have Tn plus 4. What is the relationship between 3n plus 4? As you can see, Tn is this. The term before that is Tn minus 1. The term after that will be Tn plus 1. After that, n plus 2. After that, n plus 3. Then after that, n plus 4. Then after that, n plus 5. So you know that Tn plus 4, this one is equals to 3n plus 17. They ask you what is your Tn plus 1, as they have common difference 3. So it's going to plus 3. Here we have 3n plus 20. So here we have our option. Given that Tn is equals to 2 over 5n minus 1 is a geometry sequence, find the sum of infinity. The sum of infinity is a over 1 minus r. So a is equals to t1. So 1 minus 1 power 0 is equals to 1. Then I need to find r by using t2. So 2 over 5, 2 minus 1. So it equals 2 over 5. Then the r will be t2 over t1. So it equals to 2 over 5. Therefore, sum to infinity will be a 1 minus r. So therefore, 1 over 3 over 5. So 5 over 3. 1 divided by 3 over 5 equals with 1 times with 5 over 3 equals 8. So therefore, here is our option. Then how many terms are multiple of 3 for the integers from 102 until 198? So here they want to find out is n. Multiple of 3, we have to find out what is the number start with multiple of 3. From this number, 102, is it multiple of 3? Yes, so this is then 105, then 108, until the last term, is it this 198 is multiple of 3? Yes, so 188 is the multiple of 3. So from here we can see your first term is 102, D is multiple of 3, so 3. Then Tn is 198. Therefore, A plus n minus 1 D will give you 198. So minus 102 and divide by 3 and plus 1, it will be 33. Then which statement are correct about the geometry progression? So T4 over T3 is R. R is less than 1. Yes. So to find the sum to infinity, it will be A, which is equals to T1, then 1 minus R. So R is T4 over T3. This is correct. Then to find R, so R, you need T4 over T3. So T4 can be obtained by S4 minus S3, correct? Then T3 can be obtained by S3 minus S2, correct? So R, this is wrong. Suppose the term at the back divide the term before that. So T5 over T4. Therefore, here is our option 1 and 2. Then state the range of the x for which the expansion is valid. So first of all, when you have power negative, it is a type 2 formula. Type 2 formula must be start with 1. So 5 need to factorize out from the bracket of power of negative 1. Therefore, it also power negative 1. So when you take out 5, it is equal to 1, means you divide 5 out. So when you divide 5 out, here will be 2 over 5. So 2 over 5 x. To find the validity, we have to identify n is equal to negative 1. The star is negative 2 over 5x. So validity is the modulus star less than 1. Therefore, it is modulus negative 2 over 5x less than 1. First of all, we solve the negative first. I take out the negative. So modulus negative 1, then modulus 2 over 5x. Alright, so this we are using the concept of modulus AB. It is equal to modulus A times modulus B. So we can simplify the coefficient negative here. So now we only have modulus 2 over 5x. To open this modulus, we do basic definition. So 1 is here. In front here, we add in negative 1. Therefore, to get x, we're going to times 5 and divide by 2. Times 5 divided by 2. Here, times 5 divided by 2. So therefore, here we have our option. Next, find the third term for this expansion. So first of all, your power is positive. So this is type 1, positive integers, n is 3. Therefore, we have a is x, b is negative 1 over third x, equivalent to negative x power of negative half. So third at denominator, power will be negative, third will be power of 1 over 2. To find the third term, so n r, a n minus r, b power r. So here is r plus 1. So when you have third term, means your r is 2, n is 3 given, your a is x, substitute 3 minus 2 is 1, b is negative x power negative half, power r is 2. So we simplify. When we have 3c2, it is equal to 3. This x is power of 1. And then negative 1 square, x power of negative 1. So negative 1 square still positive. Now we have x minus power 1 minus 1. So x power 0. Therefore, it is equal to 3 only. So here we have our option. So that's all for this.